This is a circle and this is a chord. If I draw a line from the center of a circle that is perpendicular to the chord, then that line bisects that chord, meaning it cuts the chord into two equal parts. Theorem 1 states that if a line is drawn from a center of a circle, perpendicular to a chord, that line bisects the chord, meaning it cuts the chord into two equal parts. We are given a circle with center O. O is the center. OM is perpendicular to AB. OM is perpendicular to AB. And AB is a chord. Right? So we are required to prove, RTP means required to prove that AM is equal to MB. AM is equal to MB, meaning we are required to prove the theorem that states that a line drawn from a center perpendicular to a chord bisects that chord. In order for us to tell that it bisects this chord, we need to show that AM is equal to MB. We are going to prove that. So in order for us to prove that a line drawn from a center perpendicular to a chord bisects the chord, we need to construct, right? So we need to construct. When we construct, we use dotted lines, right? So we need to join OA and OB. Join OA and OB. And by doing that, we have created triangle OAM and triangle OMB. Now, the reason why we make two triangles is we want to prove that this triangle is exactly the same as this one. And in Euclidean geometry, when we say two shapes are exactly the same, we mean they are how do you write it? Congruent.
It's congruent with a G.
To one another. Congruent means exactly the same. We use three parallel lines as a symbol for congruency. So we need to prove that triangle OMA is congruent or exactly the same to triangle OMB. If these triangles are exactly the same, then we can prove that this length from triangle AOM is equal to this length from triangle OMB. So that's our goal. To prove congruency, we need to say in triangle OAM and triangle OMB. 1. Length OA is equal to length OB. Why do we say these lengths are equal? It's because OA is a radius and OB is also a radius. And a radius of a circle is always the same length regardless of where you draw it. So OA is equal to OB because they are radii. 2. Now we know that these two triangles are attached to one another back to back, right? So they share this length OM, right? So that means OM for triangle OAM is equal to OM of triangle OBM, right? So OM is equal to OM. Why do we say that? Because OM is common, is a common side. The third reason, so we only need 3 reasons to prove congruency, right? So the third reason is, since they gave us that given OM is perpendicular to AB, it means that angle OMB is 90 degrees, right? And this is a straight line. So if it is 90 on this side, then this angle is also 90 degrees, right? So let's say this is M1 and this is M2. So if they gave us that angle OMB is 90 degrees, then therefore we can conclude that angle OMA is also equal to 90 degrees. We say angle M1 is equal to angle M2 is equal to 90 degrees. that information was given to us. So therefore, we can conclude that triangle OAM is congruent, meaning it is exactly the same. These two triangles are exactly equal to one another. Is congruent to triangle OMB. So the reason for that is these radii that we say they are equal, they are actually hypotenuses, is that a word, of these two triangles, right? So this is hypotenuse. OM is equal to OM. This is a side, and angle M1 is equal to angle M2 is equal to 90 degrees. This is a right angle. So the reason why we conclude that these two triangles are exactly the same or congruent to one another is because we have a right angle and a hypotenuse and a side. So since we have proven that triangle OMA is exactly the same to triangle OMB, meaning this angle is equal to this angle of this triangle is equal to this angle of this triangle, and this angle of this triangle is also equal to this angle of this triangle, then that congruent shapes have equal angles and equal sides. So we have proven that OA is equal to OB, OM is equal to OM. Therefore, we can say that AM is also equal to MB because these two triangles are exactly the same. So therefore, AM is equal to MB. So by saying this, we have proven that AM is equal to MB, meaning that a line drawn from a center of a circle, this line drawn from a center of a circle perpendicular to a chord bisects that chord, meaning length AM is equal to length MB. This is how you prove the first theorem in Euclidean geometry grade 11. Thank you for watching.
It's easy to see when you look at me. If you look closely, Mystic don't back down. Subscribe to this channel if you haven't already, so that you can get that A in mathematics. Leave a comment down below if you have a question. Mystic will make sure you get the answer.
Leave a like and share this video with your friends so that we can all be good. Thank you for watching.